All right, so we have a coin and an unbiased six-sided die. If the coin shows tails, and okay, so if the coin shows tails, then the score on the die is his final number of points. But if the coin shows heads, then you get one extra point on top of what you got on the die. Okay, so for this, when you have like when you're doing two different events and the total of those events is being counted, a good way to like show your sample set, show your possible outcomes is to use a two-sided table, okay, or two-way table. So we can say that, the coin, so this is the coin stuff, so you can get a heads or a tails. That's the coin. And on the die, you can get a one, two, three, four, five, or six, right?
Hmm.
So now, if you get a heads, then, sorry, if you get a tails, then the die is directly what your score is. So one, two, three, four, five, six. Because if you get a tails, it's just whatever you got on the die, that's your answer, that's your score. However, if you get a heads, you're gonna get one plus the score. So this is gonna be two, three, four, five, six, and seven. Okay. So this is your sample set basically, right? These are all the possible outcomes you can get from this experiment. Okay. So
Is
this
that
will
like
help you. Uh-huh.
a rule or something?
Rule for what? Which part? The two-sided
Uh,
table or the fact that I'm adding one when I get a heads?
yes, that one.
No, it's written. So if it says that if you get tails, the score is exactly what you got on the die. However, if you get heads, then you're gonna add one to the score on the die.
Mm-hmm.
So when I got heads, I'm adding one to the score. So I could get a heads and a one, which would give me a total score of two. I could get a heads and a three, for example, I would get a total score of four. If I get a tails and a five, I will get a total score of five, because tails mean I don't add one. I just write down the final score. That's it. Okay. So what's the probability that the first part says what's the probability that the final score is seven? Okay. How many total options do we have here? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total options. How many of those options end up with a 7?
One.
So the final answer would be 1 out of 12. That's one way to do it. Another way to do this would be to simply check what is the outcome that results in an outcome of 7. You could get a heads and a 6, right?
Mm.
What's the probability of getting a heads?
Two.
No, no, that's not
One.
2. 1 over 2. It's
Uh-huh.
50-50, right?
Yeah.
And what's the probability of getting a 6 if you have 6 numbers on the die? So on a die, how many ways can you get a 6 basically?
One.
One. And how many total things can happen when you roll a die?
Six.
Exactly. So you multiply the probability of getting a heads with the probability of getting a 6, which would
Mm.
together provide you with an outcome of 7, right? And this also gives you 1 out of 12 because that's how probability works. So you can find it both ways. By counting the total number of ways you can get a 7 and dividing by the total number of things that can happen, or by figuring out what would need to happen for you to get a score of 7. You would need to get a heads and a 6. Okay?
Okay.
And that is why I multiplied the probability of heads and 6. So now we can fill in the rest of this table using the same idea. So what's the probability of getting a 1? A final score of 1. What do you
Um,
think? So how many ways can you get a 1 divided by how many total things can happen?
one of
So
what?
1, just the final score of 1. How many ways can you get a 1, a final score of 1? So in this list, how many different outcomes result in a final score of 1?
Once.
Once. Yeah, there's only one way to get a final score of 1, right? And how many total things can happen? How many total outcomes do we have in general?
12.
12. So 1 over 12 is the probability of getting a final number of 1 point. Similarly, what's the final probability of getting a total of 2?
Two.
2 over?
12.
Sorry?
12.
12, exactly. What's the final probability of getting a 3?
Also two.
Not just 2.
2 over 12.
Exactly. Probability has to be between 1 and 0. It cannot be 2. What's the probability of getting a 4?
2 out of 12.
Exactly. Same with 5, and same with 6, and only one option with 7. Because there's only one way to get a 7, right? And only one way to get a 1 and a 7. But the rest of them all have two options, right? Okay, so now this is called your probability distribution table, by the way, because you have all your possible outcomes are listed here, right? These are the ultimate possible outcomes. You can only get 1, 2, 3, 4, 5, 6, or 7 as your final score. And you've written down all the probabilities of getting each of them. So this tells you a probability distribution, okay? Now, just a reminder, since this is a valid probability distribution, two things are true for this. Number one, each probability is between 0 and 1. Extremely important, okay? So this tells us that this probability is correct. By the way, I'm telling you extra stuff now. So in a question, they may say, can you tell us whether this probability distribution is valid? For a probability distribution to be valid, two things have to be true. Number one, each probability individually has to be between 0 and 1. Okay, each probability is between 0 and 1. It's not more than 1, less than 0. Okay. Number two, the extremely important thing is that each of the probabilities, all of them added up, have to be equal to 1. Okay. So every single probability has to add up to a total of 1. If it doesn't, then this is not valid. We can check if it adds up to 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total is indeed 1. Totals to 1. So this is also showing us that this is a valid distribution. Okay. So these are the two rules that you need to check if someone asks you if a given probability distribution is valid. Okay. The total probability is 1 and each individual probability is between 0 and 1. Okay.
What is the first point again?
Each probability alone, so like each of these numbers is between 0 and 1, isn't it? You can check if you convert this to decimal, you will see that it's between 0 and 1. Okay. So each of them are between 0 and 1. Of course they are, by the way, because like if the top number is smaller than the bottom number, you're always going to be between 0 and 1. That's how fractions work.
Yeah.
Yeah. So every single one has a top number smaller than the bottom, which means that every single probability individually is between 0 and 1. Because probabilities cannot logically be more than 1. Because that would mean that somehow it's more than 100% sure that something's going to happen. It's impossible.
Yeah.
So that's why each individual probability has to be between 0 and 1, and every single probability must add up to a total of 1. Is everything clear? Okay. So finally, the next question says, calculate the expected value of the final number of points. Remember, if you have the probability distribution, expected value is the easiest question ever. All you're supposed to do is multiply each score with its probability and add it up. Okay, and that's it. All right, that was long. So this is the expected value. You basically just need to make this sum, and that's your answer. Expected value, by the way, means the value or the score that you expect to happen if this guy does this experiment. Okay. So by doing this whole calculation, you will find the expected value, and that's basically it. Okay.
Okay.
All right. So that is this question. Any questions?